Assistant Professor in Ajay Kumar Garg Engineering College. Today's the topic of discussion is error detection, which is the basic part of data link layer in computer networks. So let's start with that. Now, what is an error in computer networks? When a sender sends some message, it is being sent in the form of combinations of zeros and ones. Means the number of bits are being sent from the sender to the receiver. Now, if the message sent by the sender is not received by the receiver, or the receiver, the message is received by the receiver but not in the form which the sender has sent, then it is considered an error. Now let us suppose the sender is sending 0101 and this is sent by the sender, and the receiver is receiving 1101. This bit has been changed. Receiver is receiving the message but not that message which the sender has sent. So this type of things are called errors in computer networks. So there should be some methodology where the receiver should know the message it is receiving, whether it is correct or not. So we will be discussing various error detection techniques in this lecture. So types of errors like single bit error and the burst errors. Single bit error is the error in which only one of the bit is changed. Like you can see that this is the data sent by the sender, and you can see this colored bit, it is changed, this 0 is changed to 1. So receiver is receiving this data. Now there is a single shift in the bit, means one bit in the data is changed. So these type of errors in which only, now burst errors when multiple bits are being changed, like you can see in this is the whole data which is sent by the sender, and these colored bits are being changed when it reached to the receiver. So these type of errors are called the burst errors. Now error detection, right? Error detection uses the concept of redundancy, which means adding extra bits for detecting errors at the destination. Now what the sender is doing, when sender has to send some data to the receiver, this is the receiver, this is the sender. Now this sender has to send some data to the receiver, and this sender will add some extra bits, like this is the data which is to be sent to the receiver. With this data, some extra bits, some redundant bits are being added, so that the receiver can use these redundant bits to see that whether the data sent by the sender is, which it is receiving, is same or not, right? If there is some discrepancy, that means the data is lost or some data has been changed, so it discards the data if they find some errors, right? When this data is being received by the receiver, it will check whether it is right according to these data, and if it is not, it will reject the data. If it is okay, then it will accept the data. This will be the whole procedure of the error detection. Now various methods to detect errors is Parity Check, Cyclic Redundancy Check and Checksum. Right, in all these three methods we will be adding some of the extra bits, means redundant bits, to tell the receiver or to help the receiver to check whether the data it is receiving is correct or not, right? Now let's start with the parity check. Parity bit is added to every data unit so that the total number of ones becomes even for the even parity check or the odd parity check, right? If the data which we are sending is having odd number of ones, we will add a single one at the last, right? If this is the data which is sent, if it is having some odd number of ones, we will add one here, right? If the number of ones is even, we will add a 0. This is the extra bit, redundant bit, which will be telling the receiver that the number of the ones is even or odd. Now suppose this is the data which is to be sent. Now suppose now we are sending these, how many ones are there? There are 3 ones, that means odd ones. So extra bit we will add 1 here. So when this data will be sent to the receiver, now receiver will know that the number of ones in this is odd, because here it is 1. So if one of the bit is changed, now let's suppose this bit is changed and it has become 1 at the receiver end. So he will see that here it is written 1, but there are even number of ones. That means something has wrong, some bit has been changed, some error is there. So it will reject the data. Similarly, you can see here, this is the data which is sent by the sender node. Now it will see there are 3 ones, so we will add 1 here, right? And then this data will be sent to the receiver. Now receiver will count the bits, it will check this, then the number of it should be odd number of ones. But if they are even number of ones, then it will reject it, otherwise it will accept it. Now if in case of very long data which we are to send from the sender to the receiver, what will be done, this data will be divided into different blocks, and each block will have a parity bit with it. This block will have this. See, for the first block, 1, 2, 3, 4, 5. So 5 ones, to make it even we will add 1. Similarly, we will do for the second block, 1, 2, 3, 4, 5. This one is 6, making it even. 1, 2, 3 and 4. This is already even, so no need to put 1 here. 1, 2, 3. These are 3 ones, so we will put 1 to make it even. This way we will create a parity bit for every block, and then we will send these frames with extra bit to the receiver. Now receiver will check this bit and see that the error, if there is any error in this particular frame. Similarly for this and this, right? So here this is called a 2-dimensional parity check. Now the next method is cyclic redundancy check. Here also we have to put some redundant bits to help receiver to check whether there is an error in the data or the data is free from errors. The CRC is a network method designed to detect errors in the data and information transmitted over the network. CRC is performed by binary solution on the transmitted data at the sender side and verifying the same at the receiver side. At the sender side, some of the binary modulations are being done on the data and it is then sent to the receiver. The same binary modulations are done by the receiver also to check whether the answer which is it is getting is same as the sender has sent or not, right? The term CRC is used to describe this method because check represents the data verification, redundancy refers to the recheck method, and cyclic properties to the algorithmic formula. To understand the working of CRC method, we will divide the steps into 2 parts. In the first step is to add the number of zeros to the data to be sent, calculated using k-1. K is the bits obtained through the polynomial equation, right? First, there is a polynomial equation involved in it, which the sender and receiver will have. This polynomial will be placed in both sender and the receiver side, right? Now we have to see that what is the number of bits of the polynomial. See here, 1, 2, 3, 4. If there are 4 bits and we will be adding 3 bits, means k-1 bits will be the extra bits which we will be adding to the data, and then we are sending to the receiver. Applying the modular binary division to the data bit by applying the XOR operation and obtaining the remainder from the division. Now here we will be performing the division, right? For data with this polynomial, data will be the number of bits which we are sending to the receiver, that will be divided with this polynomial. right? And whatever the remainder is being achieved by the division, that will be the added to the number of bits, and that will make the entire data that is to be sent to the receiver. The last step is to append the remainder to the end of the data bit and share it with the receiver. So receiver will receive the data plus the remainder of the division, right? This is the data which the receiver will be receiving. Example, the data bit is to be sent. Suppose we have to send this data and the polynomial equation is this, right? Now what will happen? To check the error, perform the modulo addition again and check whether the remainder is 0 or not. Now, at the receiver side, what the data is has been received, it will again perform the modulo division with the same polynomial, and it will check whether the remainder is 0 or not. If the remainder is 0, that means the data received is fully correct. It is error free. If some other bits are being received other than 0, that means the data is changed somewhere and there is an error in that, right? If the remainder is 0, the data bit received is correct without any errors. If the remainder is not 0, the data received is corrupted during the transmission. So the data bit to be received is this one and the polynomial equation is this one. So see here, sender will first see the data and according to the polynomial it will add these n bits, right? Divisor will have those bits, means the polynomial is converted into the bits and that is called the divisor, right? Then we will divide this data with this divisor and find out the remainder. That remainder will be added with the data and sent to the receiver, right? Now receiver has received the data with the remainder bits also. Then it will again perform the division and find out the remainder. If the remainder is 0, it will accept it, otherwise it will reject it. Now let's take one example. Suppose the polynomial is x3 x plus x2 plus 1. First of all, we have to convert it into the bits. X raised to power 3, right? So the coefficient of this is 1, so we will write here 1. Then becomes, after x cube becomes x square. X square also coefficient is 1, we will write 1. Then comes x raised to power 1. We cannot see x raised to power 1 in this, so we will write 0 for x raised to power 1. Then x raised to power 0. The coefficient is again 1. We will write here 1. Right? Now this polynomial is converted to this number of bits. And this is the data and this is the divisor now. Right? This is the data. Now you see, this is our divisor which we have converted and this is the data. Right? We know that k minus 1 bits we have to add. Now how many bits we have? 1, 2, 3, 4. 4. That means 3 bits are to be added extra. So these are the 3 bits which we are adding to the data. Now in the earlier stage we do not know what bits should be there, so we insert 0 in that. Now we will perform a XOR operation between the data and the divisor. We'll write the divisor here 1, 1, 0, 1. Right? 1, 1, 0. Now in XOR operation, if the same bits are there, then the answer is 0. If the different bits are there, then the answer is 1. So here we can see that 1 and 1 same bits, so answer is 0. 0 and 1, they are different bits, so answer is 1. 0, 0, 0, 1, 1, 0. And to perform the further division, we need 4 bits. So we will bring 1 0 here and make it 4 bits. Then again we will perform the XOR operation with the same divisor. Again we can see that 1 1 is 0, we can put 0, 0 and 1 1, 0 0 0, 0 1 1 because they are different. Again we have to make it 4 bits, we will bring 1 0 from upper side and again perform the XOR operation. Similarly we can do 1 1 0 0 1 1 1 1. Again fourth bit is brought from up. Again perform the XOR operation. 1 1 1 1. These all will become 0 and 1 1. This 1 1. Now what will happen? As we see, there are 3 bits, right? 2 bits, sorry. We have to make it 4 bits. So we have to bring 2 zeros from upper side, 0 and this also 0. So this will make this. Again, we will perform this one division there, XOR operation with this, and this is the final remainder, right? And from the these bits are now inserted here in place of this 0 0 0 1. Right, these are our CRC bits, and these bits are being sent to the receiver. Now we can see here the receiver has received this one 1 0 0 1 0 0 0 0 1. Right, now here the work of the sender is finished. Now the bits are being sent, the receiver is received these bits, and again the receiver will perform the division again, right? Now you can see there we will perform the XOR operation again. See here 0 1 1 0 0 0 1 1 0 and again 0. We will go on performing the XOR again and again, similar to what sender has done, and ultimately we will see here we will receive the remainder as 0. This means that all the bits that are being received, these bits are correct. Means there is no error in that. If, for example, the receiver may have received this, in place of the 0, it has received 1. So when we will calculate the modular division and performing the XOR operation with the sum of the bits from that, it may contain 1 at some place. That means there is an error in the data. The third method is the checksum. Checksum is an error detection method. At the sender side, m-bit checksum is used and data to be transmitted into different segments of m bits. All the m-bit segments are added and the result of the sum is then complemented using 1's complement. The actual technique is the data is divided into m blocks, m bits and different blocks. These all bits are added together, and after we find out the sum, we have to take the 1's complement of that. 1's complement means we have to reverse if there is a 0, we will put 1. If there is a 1, we will put 0, right? And then we will send it to the receiver. Okay? And the data along with the checksum value is transmitted to the receiver. So here we will be performing the binary addition. So there is a revision for the binary addition. 0 plus 0 is always 0, 0 plus 1 is 1, 1 plus 0 is always 1, 1 plus 1 is 0 with 1 carry, and if there are 3 ones, 1 with 1 carry. If there is a carry at the last, because we have not to change the number of bits, if there is a carry at the last, we will take that carry and add that in the lower significant bits, right? Now, all the m segments are added along the checksum, the value is obtained and complemented and result is checked. This is at the receiver side. If the result is 0, after taking the complement, if the resultant is 0, that means the receiver is able to make out that there is no error in the data, right? And receiver accepts that data. If the result is not 0, receiver assumes that error contained during the transmission. The receiver will discard the data and ask the sender to retransmit it, right? Now let us suppose the original data is this one and it is divided into 2 blocks, right? And we will add these blocks, we will generate the sum, right? And then we will take the 1's complement here, we will reverse the bits and we will, this is our checksum and we will send all this data to the receiver. This is the data bits and this is the checksum which we have calculated from here. This is sent there. Now at the receiver side, we will receive these 3 bits, these 3 blocks, sorry. We will add these 3 blocks, we will calculate the sum and then we will take the ones complement. Here we can see that the ones complement, after doing all the calculations, at last we are receiving 0. That means the data is correct and it is error free. Thank you very much.